So let's do some practice problems with limits. So let's take a look at the limit as x approaches -3 of 6 plus 4x over x squared plus 1. So obviously the very first thing you have to do is, or at least try, is direct substitution. So if I directly substitute x equals -3, or -3, 4x, I'll get 6 plus 4 times -3 over -3 squared plus 1. So if I evaluate it further, 6 plus 4 times -3, which is -12, over -3 squared, which is 9, and plus 1. So 6 plus a -12 is the same thing as 6 minus 12, so that's -6, over 9 plus 1, which is 10, and we can simplify that to -3/5. So let's take a look at the limit as x approaches -5 of x squared minus 25 over x squared plus 2x minus 15. So obviously the very first thing is to direct substitution. So to check with direct substitution, I won't normally plug it into the entire thing, but I'll just plug it into the denominator, because if I get 0 on the denominator and I cannot divide by 0, so then I cannot evaluate my equation. So if I plug in -5 to the denominator, I'll get -5 squared plus 2 times -5 minus 15. -5 squared is 25. 2 times -5 is -10 minus 15. -10 minus 15 is -25. I'll get 0. So I cannot evaluate it because I cannot divide by 0. So we're going to have to go back So now I need to manipulate my equation so that I can evaluate it. So looking up here with x squared minus 25, that's a difference of squares, so I can actually factor that into x plus 5 times x minus 5. And for this bottom one, x squared plus 2x minus 15, I can also factor that. I need to find two numbers that equal when multiplied, -15, and when they add I get to 2. And right now I'm thinking about -3 and 5. So if I put x minus 3 and x plus 5, when these two are multiplied together I get x squared plus 2x minus 15. So that's how I know I've factored it properly. And now you can see that x plus 5 and x plus 5 actually cancel. So I'm left with x minus 5 over x minus 3. So now I can go ahead and plug in -5 to the equation. So I get -5 -5 minus 5 over -5 minus 3. -5 minus 5 is -10, and -5 minus 3 is -8. So then that will leave me with the negatives canceling, and I get 5 over 4. So for number 3, obviously when you plug in 4 using direct substitution, 4 minus 4 equals 0, so I cannot do that. So I'm going to have to go back and try to manipulate this equation. So what I can actually do is, x minus 4 is a difference of squares. So I can change that or rewrite it as the square root of x minus 2 times the square root of x plus 2. And if I FOIL this, I'll get exactly x minus 4. So now that I have that, the square root of x minus 2's can cancel, and I'm left with 1 over the square root of x plus 2. And now when I plug in 4, I'll get 1 over the square root of 4 plus 2. The square root of 4 is 2, so 1 over 2 plus 2. That gets me to 1 over 4.